not, then I will call on Stefano Macali to present the next presentation. So Stefano is a researcher at CREA. He's a microbiologist with a broad experience in soil microbial ecology and biogeochemistry. Stefano is going to refer to the Minotaur project, which is modeling and mapping soil biodiversity patterns and functions across Europe. So a key area and an area where a lot of new knowledge is required. And Stefano, your presentation is prioritizing and selection of soil health relevant biological indicators. So over to you.
Thank you, David. I'll try to share my screen. So can you see it?
Yes, so if you put it on full screen then, Stefano.
Yes. Okay.
Yeah, perfect.
Yes, okay, perfect. So thank you. This presentation is strictly related to the previous one, with a specific focus on soil biological indicators, how to select these indicators, the criteria we are discussing within Minotaur project. Minotaur project is, as you said before, an internal project which is mainly focused on the provision of policy relevant biological indicators, because the final goal is to provide models, maps, but also validated reference values for monitoring purposes. So we are dealing with soil biodiversity in terms of taxonomical diversity, but also functional diversity. So the core business of the project is the selection of such bioindicators based on data collected from EJP SOIL partners, of course, and also from external European data sets, as well as on their ability to provide ecosystem services. So these indicators will be tested under field conditions for their sensitivity to specific bioclimatic conditions, management and fertilization practices, and all this information will be used for modeling and mapping. So the first question is why such bioindicators are so relevant to us, and not only to us. So this is because most of the ecosystem services we know in terms of provisional, regulative, or supporting type are driven by soil biota. So, and not only for provision of food, but also for carbon sequestration, water purification, climate regulation, nutrient cycling, and so on. So soil biota and its biodiversity plays a key role on this. So you can imagine the relevance of such component of soil for our planet, for soil, of course, but also for our health. So it's quite surprising to see how no biological indicators have been included in the list of indicators used for the assessment of soil health objectives. And this is not due to the absence of indicators, rather to their heterogeneous application over time. In fact, there are plenty of examples of European projects that have applied such biological indicators over the last 2 decades, like Envaso project, EcoFinder project, Landmark, and so on. But the point is that this heterogeneity in terms of biological target, or in terms of methodology applied, or even in terms of experimental conditions, made it rather impossible to find out a common consensus on biological indicators to be used. And this situation is still actual, as we saw before, after Antonio's presentation, where it's quite evident the number of biological indicators available, but their scarce application across European member states. In particular, if you give a look to the implementation level of such biological indicators across the 24 EJP SOIL member states, we can see how just few countries have implemented such indicators. And I highlighted in green the most common indicators: soil respiration, which indicates an overall biological activity, let's say, which has been implemented in 7 countries so far. The determination of microbial biomass, which gives us a broad idea about the amount of living biomass in soil, as well as earthworm abundance and composition determination, which has been conducted on 6 countries. So compared to the 24 countries of the EJP SOIL family, rather few countries have adopted these indicators, and few of them establish clear reference, threshold, and target values for each indicator. So this is the starting point we used for discussion within Minotaur. We took into consideration these results, but we also like to consider the functional role of such soil biodiversity, because we know that soil hosts more or less 1/4 of the entire biodiversity of the planet. And such huge amount of life is organized in a very complex and dynamic living web. So nevertheless, such organisms can be classified into 3 main functional groups. The first one is called chemical engineer, okay, which includes most of the smallest organisms in soil, mainly including microbes, such as bacteria, fungi, archaea, and so on. But despite their small size, they play very key and important role in soil for the composition of organic matter, of plant residues, for recycling of organic compounds, for guaranteeing the nutrient cycling, as well also as to provide a very important action in bioremediation. So second group is called biological regulators, and includes a very heterogeneous group of living forms, ranging from microfauna like nematodes, for example, up to mesofauna like colembula, mites, acari, and so on. And this group of organisms play a very important and crucial role in regulating the biological activities carried out by chemical engineers by means grazing, predation, or parasitism, and they are very good biocontrol group against soil-borne pests and diseases. Last but not least, the ecosystem engineers, which are composed by the biggest living forms, invertebrates, of course, like earthworms. Their main role is to guarantee the soil structure, soil matrix, with moving soil, creating tunnels, holes, guaranteeing water, air fluxes, and spaces for other soil organisms. So together, these 3 groups of biological diversity contribute in parallel to guarantee all the main soil processes that are relevant for the provision of ecosystem and services and functioning. So we decided to consider this relevant diversity at the functional level to select our biological indicators for soil health assessment. So this is the first attempt of our proposal of a 2-tiered system of biological indicators, which is essentially based on the selection of 2 groups of indicators. The first one is functional indicator group, including microbial biomass, microbial respiration, and enzymatic activity, as an example of indicators for overall biological activity in soils, but also including structural indicators, most focus on biodiversity and taxonomic features of soil, including macrofauna, earthworms, mesofauna, nematodes, and microbes. All these indicators have been scientifically proved, of course, and the methodology is very well established. There are also ISO methods available for each of them, and these methods have been evaluated, and they are easy and cheap, so really cost efficient. And they are all sensitive to the main soil degradation processes like decline of organic carbon, desertification, erosion, soil sealing, pollution, and compaction. So in our point of view, this is a very important and relevant group of indicators that should have the highest priority in terms of selection. But of course, these are not the only indicators available. The other relevant issue that we consider is that such indicators have been broadly applied at national scale across Europe, in the Netherlands, in France, in Germany, in Italy, in Belgium, and other countries, with the very encouraging results. And of course, as I said before, many other indicators might be added. So we started to prepare a second tier level, including more specific indicators for specific groups or for specific functions. These indicators maybe are very well established in certain conditions, but not always. So this list is still incomplete. Some more indicators might be added, of course, but this is still in progress. And as you well know, the project is expected to conclude on the late 2024. So we will be able to implement this table in the next future. An important comment I'd like to say is regarding the criteria we should have in the selection of such indicators. So how many indicators should we consider? Maybe just 1, 2, or 3 of them. So we recommend to avoid the application of a single indicator, which might be very often misleading, because, for example, it's very well known that high values of organic matter in soil, it's a very good proxy of high biodiversity level and soil health level, but this doesn't mean that soils with low amount of organic carbon may be considered like unhealthy soils. So just to let you better understand the criteria we use in the selection of the first group of tier 1 indicators. So it's very simple example, but just to let you know. So if you want to establish the status, this health status of the soil, you should consider this environment. Imagine soil like a city. So if you apply the most common biological indicator like soil respiration, the information you get is the amount of CO2 released by such unit of soil in a specific time, which is very useful to say if this soil is living or not, but is not that informative in terms of which processes are involved or which organisms are responsible of the release of such gas, or which carbon substrates are used. So if you compare two soils, you can compare the amount of CO2 released, but you cannot say if one soil is healthier than the other one, because of course you need to know which is the amount of living organisms that are responsible of such respiration. For example, you need to know if a specific amount of CO2 is produced by few living forms or many organisms. And this is the same for the cities. If you compare two cities in terms of efficiency or healthy level, you need to know how many citizens are there. So microbial biomass determination is useful, but it's not, again, informative enough in terms of who is doing what, because such organisms can be more or less active very low active or high active. So we need to add an additional indicators providing information regarding the main actions and processes occurring in a specific soil. So this is an example of a minimum data set of functional indicators that might be applied. And this is very useful to get information at, related to the overall action and activity of a soil. But this is not informative in terms of who is doing what. So what about biodiversity? Which are the actors of such overall activity? So this is why we need to add the specific indicators of soil biodiversity, applied in terms of chemical engineers, biological regulators, as well as ecological engineers that can guarantee the main steps of a soil ecosystem, which is very similar to the society that can be hosted by a city like this. So we need to know which are, if organisms able to provide food, energy, or recycling are there, if there's enough organisms responsible for biocontrol, for safety, or regulation purposes, but also constructions of infrastructures that, of course, are needed, because you can have this biological potential, but without proper infrastructure like streets, buildings, and so on, this potential cannot be expressed. So the same for the soil. If you have organisms over there that have the potential to do something, they need to be considered in a very specific context. So you need to specify, integrate this information with, for example, chemical, physical features. You need to guarantee the biological functions within a specific soil structure, type, pH, nutrient status, and so on. So for concluding, these are my main take-home messages. So standardized and scientifically proven and cost-effective biological indicators are available. So we are working on a proposal of a two-tiered system for biological indicators for soil health assessment and monitoring, proposing a minimum data set that has to be established, and we aim to include this in the deliverable 6.5 of EJP SOIL. But we recommend to include both functional and structural bioindicators, because this is needed to better plan eventual solutions and restoring actions for land managers and so on, and in case of degradation threats or processes. Okay. And as I said before, biological indicators cannot be used alone, but should be contextualized with other indicators, chemical, physical indicators, but also with a specific scenario features like soil type, land use, climate conditions, management, and so on. So we recommend an holistic based integration of different multiple soil health indicators. And we are still in progress, as I said, so we are working on the validation and refinement of such indicators, their sensitivity under different field conditions. And we are also working on the establishment of, target values, threshold values, range values of such indicators. So that's all. Thank you for your attention, and I'm here for any question.